Yeah, and the last part, I did fix something off stream. So what we are going to do now is to not send the do fill signal again when we're only going to use the cached values anyway. And then things should work again. So here we are mimicking a nested for loop that runs over all the characteristics. So the outer loops will already have the same value a few times on a row. Let's say we have two for loops inside each other, two characteristics, and both run from 0 to whatever, 3. Then the outer loop is going to do, so the inner loop is going to do 0, 1 and 2, and then while the outer loop is 0. In other words, the outer loop value is going to be 0, 0, 0, while the inner loop is changing. And then the outer loop is changed to 1, and then to 2. So the outer loop is doing 0, 0, 0, 1, 1, 1, 2, 2, 2. And the inner loop is doing 0, 1, 2, 0, 1, 2, 0, 1, 2. Now this returns false if the value doesn't change. So the outer loop, the first time we set that this is the value. So we set this past 0 here, and then it returns true. But then the next time, only the inner loop is changed and the outer loop is still 0. So we call set fill index with the value of 0, but it was already 0 because that's what we did last time. And then it returns false. So then for the outer loop, this bit is not set, and therefore we do not send the do fill signal. But things still go wrong for the inner loop. Because that changes when we go 0, 1, 2, and then we go back to 0, then it changes from 2 to 0. And now we start all over again, while in fact that value, whatever I did for the value 0 is already cached. So I don't no longer want to increment this or set this bit for any characteristic, and that's this I here that runs over, it enumerates all the characteristics that have already reached the end of the range once. Now, I think I'm just going to use a bit mask, just like I'm using here already, because I don't know how else to do that. Alternative would be adding, say, a boolean to m characteristics, but that grows memory size equally. So I'm going to invent a bit mask of tasks that already finished all fill index values. Now I need to give it a different name. In fact, this should be set before that, I think. Of course, it doesn't matter where you declare it, but I like to put things more or less in the order in which they are changed. Let's call it completed. Usually I like to use a different word in the comments than in the variable name, because then you add more information. But in this case I decided to use completed in both cases. Let's add more info though, at least once. Okay, so of course we have to start with all these bits being 0. Not sure where that is currently being initialized. It's being initialized here. So the top of the multi-loop, it's multi-loop inner body. Okay, this is in the inside, in the inner for loop here. Then we set it to 0. Well, whatever. In this case, I really needed to be set. When do we need to set this to 0? Just new value. I guess just before we start the multi-loop, the nested for loops. Okay, here the range count is initialized, so that's the place. So let's add it here. Maybe the other way around. Yep. And then are going to set this at the moment we return to 0 for a certain for loop, and then I can use it in this part. Now set fill index has a side effects, it's not just a test, so this has to be called. And then after we call that, I can test if I want to enter this scope here. And we should only do that when the bit is not set yet. Right, so if completed has its bit set, bit number I, then we will not set the bit in this variable, and therefore we will not. What happened? Set it to 0. We will not set the bit here. Oh, okay. So then here this will not be set, and we will not set signal. Okay, what is this? It's being set again. So we're talking about the characteristic that's not a range, so it doesn't run 0, 1, 2, it just has 0. If that's the inner loop, then we do it once, just the loop is the size of 1. And then we change an outer loop, and then we do the inner loop again. So we got the feeling that we would do this again then. And I don't want that, because it is, well, it's already cached also. So I think I do not want to do this if completed is set. So in this case, this is not set because completed was set. But I would set it again anyway if we don't need a do field signal. I think that's wrong. So we have to do something like if not completed, then we can then we have to do that. So then for both for ranges and for non-ranges, the bit must be set as soon as we are done with the last value, and not when we start over, because then it would not be set in this case. Not 100% sure I'm doing this correct though. So theoretically we have something like well, put it somewhere. Now, so we have something like a for loop. Say int a is 0 to and then we have a few for loops. And there might be a loop that is not a range, which is basically just means less than 1, you know. And in this case that is the inner loop. And let's say for a random loop somewhere in the middle, I want to set the be completed here, yeah, at the end of the loop. That then even would work for something like this, which is not a range. Yeah, and likewise for C and A. So you just have to set the bit directly after the loop. Independent of the size. So that the first time we run through the loop, it's not set, but if there is a loop outside of it, so a more outer loop, and therefore we go to the top after setting be completed is true. We go to the top again. Then the next time we enter the bit for B is set. So already ran through it. Yeah. So this is what I want. You need to set the bit for well, some loop when we left the loop for the first time. And then we have to figure out how that works with multi-loop. Let me look for multi-loop. Here's my documentation. Well, this is the beginning of all loop code. How to do breaks and continues. The inner loop. Loop start values. End of loop code for loop. That's all nice, but what does that mean? End of loop code. Does that mean that it's after the loop, or that is code inside the loop but at the end? I hope after. Let's say the inner loop is easiest to understand. So let's say this is the inner loop. Then it looks like it says while the loop variable is less than 3, we do this, and that then would be the inner loop. So this would be true inner loop. And then end of inner loop. And then we do start next loop at ML. And then we go to top of the while loop. Did ML get incremented in here? Start next loop at. Alright, okay, so this says if we are not in the inner loop, start the next loop. But if I said we are in the inner loop, then we just increment the current loop. So M counters M current loop is incremented, and ML is this thing, which exactly returns that. So this part is not executed, for the inner loop at least, and therefore probably not in general, until that loop finishes. So we must set a bit in this part here. So now to figure out where this is, and then how to add that. This is after the while loop. So when the while escapes. So you must have some kind of test for the while loop, and then after that escapes, after that is false, we get to the point where we must test this, do this test. Now I have to find that back here, because this again is has another order of complexity over it. Top multi-loop while loop. It says we are now at the top of the while loop. It's here. And I want to know where we break out of it. I guess this is the test here, right? Yeah. This is how multi-loop normally works. We have a while something and then brace open, and that test here is being done here. So if this fails, we did not enter the while loop body, or we just left it, I think. So that is the run state is then the bottom multi-loop for loop. The bottom multi-loop while loop? No, the bottom multi-loop for loop it was. So here. Here's the same test again. So this is the while loop test. Okay, let me jump back to multi-loop to see how that worked. Because what this code currently does is call next loop on the counters after we left the while loop. I mean, I think that this means that we just left the while loop, right? So go back here. I think this part is not here. So directly after we left the while loop, that would be here. We get here, which is calling m next loop. So we call m next loop, and then we should be testing ml finished. Yeah, that's correct. We call next loop and then we test finished. So the piece that we have to add is right here. And we do an if. Why did I delete that? Because I have to jump back. Multi-loop. The test looks like this. Where ML is simply the multi-loop, I guess. The ML is the thing that we call next loop on. Oops, there must be if. And ML is the that. Okay. Pew. I think we go there. Trust me, I don't understand that either. I wrote this, and it turned out that multi-loop is absolutely not possible to understand. You just have to, you know, yeah, what I just did. and then magically it works. So now we are directly after the loop number loop. Damn it. Okay, so this is end of loop loop. Where end of loop wasn't clear, so I'm going to say immediately after after the for loop. And I don't like loop. So let's jump back to, I always forget how to set a marker. How to set a marker here? No idea. Anyone knows? Tell me. Okay, I'll look it up. M. Yeah, M is setting, and then single quote is jump to line of mark A. Just M in single quote. So I don't know, MA, whatever. And then I want to find that the do fill stuff again, where we're working on. So here I'm using I, although my I is an vector index here. But well, yeah, 2-bit mask is using a characteristic range index. To think this is I. And I would like it to be, based on it in my mouse, I would like it to be a characteristic range index, which has this type. We can do that by not by assigning it, but we can construct it from an integer. And the rest should work. And then I want to set that bit. And now we made mistakes because I said the rest would work, but no, it doesn't. You cannot even compare it with an int. Yeah, I don't know, sometimes it's maybe easier to not work with an int. I mean, what end of loop returns is, I mean, not with an index, even though it just returns an int. So let's keep it an int. At least then we can compare to 0. But then we cannot use a bit mask, I don't think. That, although, yeah, maybe we can. I think, no, yeah, it is an explicit constructor. Oops. It's a vector index, which has a explicit constructor. So it won't do implicit constructions. So yeah, I could just add type here, or I can redo the code. This code, and I don't think that duplication of code is not good, so let's not do this. And then we have to do the ridiculous thing of converting it to an index, and then immediately after that returning it back and blah blah blah. Well, the compiler will optimize all that away, I guess, so it's just going to be on assembly instruction in the end. So this is an explicit, I think we are inside pipeline. This is an explicit construction, instead of just passing I to a function that takes a characteristic range index. And then we are allowed to pass it. And then that immediately calls getValue, which I'll have to go to the vector index. So now we use the explicit constructor, this one, which sets, it's just a wrapper around the size type, so it is a size type. We assign to the size type using this explicit constructor, and then we call getValue on it, which just gets it back. So the compiler is going to be like, what are you doing? But in the end we still get something that is absolute minimum number of assembly instructions. Except that we're doing this narrowing. Sometimes that's really, really annoying. It says if I is negative and you pass it to its size type, it becomes very large. Are you sure you want to do that? Yes, because it's not negative. I can tell it in a really dirty way that it's not negative, namely to make this unsigned. But end of loop returns an int. Does it ever return something that is... Oh! No, but it can be negative. No, it must be an int. It must be an int, otherwise you cannot do this test. Okay, it doesn't read anymore, but performance is more important. So basically I just told the compiler to shut up. Shut up and compile. It's not it's not shutting up. I thought this was telling it to shut up, but no, it's still complaining. Why? And then the static cost. I think the static cost means if there is an underflow, so if it is a negative value that becomes very large, then that is exactly what I want. Just do it. Now it compiles. Good. And still we crash. Don't add the same index twice. Well, that's weird, because I would say the reason that happens, I mean, this is thread 5, so we just went back to fill index number 0. For something that is a range. So I think we also saw fill index 1 before. Yep. We did 0 and then we did 1 and now we do 0 again, and then it shouldn't even run that code. But it is. 2. And there is another group here. Yeah, it's the same. Yeah, weird. Weird. Let's run it in the debugger. Run. And crash. Shader index 1 is existing. And this is being added from here, because fill index is 0. And we are adding it twice, so we have been here before with fill index 0. That was already also printed. But yeah, the question is, why are we here? Okay, L minus. This is case. I would say we can only get here when we get to do fill signal or not. Maybe I'm mistaking. I think I'm mistaking something. I never changed the state. It's still on. Oh, right. Not sending it to do fill signal would just hang the task, I think, because it is still waiting for that signal. Oh my. I might as well just terminate the task. Set that bit and terminate the task. But still, then I expect it to hang rather than run this again, because I definitely do not want that. Why do we get here twice? Well, let's make sure that we do. Maybe looking at debug output is more useful. Let's first try to crash with a single pipeline. Is that possible? I think so. A single factory, I mean. There are even two factories now. Yep, still crash. And we crash on the same thing, and we crash in there, and we crash there. Characteristic range fill or terminate. No, this one. Fragment pipeline characteristic fill with fill index 0, so just as before. And then we want to see if we how exactly we went through this task here. So I'll just highlight that task. Maybe I should go all the way to the top and search for that. Excuse me, 1G. Constructing the task. Add it as a characteristic to the pipeline factory. Registering it as a fragment shader. And then get here, running it. It's being run, initialize. Fragment pipeline characteristic range initialize is being run. Add combined image sampler. That's the initial during initialization. And then it waits for the do fill signal. So that was initialization. Then we receive the do fill signal. Yeah. This is the first time we run it. Sorry, I lost track. Yeah, this is initialize. So we run initialize. And then we run for the first time the fill state, yeah. With fill index is 0. Waits until it may do pre-processing, so that's already after fill. Gets a do pre-process signal. It runs pre-process. Wait for the do compile signal. Gets a do compile signal. It runs a compile. And then it locks some task mutex. And it unlocks it again. And then it waits again for the do fill signal. Because, well, we have done everything including compiling. And then it gets a do fill signal. See here, signal's called on do fill. So it runs the state again. Oh no, not that one. This one runs the state again. And now with fill index 1. And now we wait again for do preprocess, and we get the signal, we do preprocess, we wait for compile signal, we get the compile signal, we run the compile state, again with locking and releasing, and now we wait again for the do fill signal, or do terminate for that matter. So okay, it could send the terminate signal, but I'm not, so yeah, I don't know. Or maybe it would work anyway. So never send it a do fill signal, then this task just doesn't run until the whole factory finishes. And then I guess it might send terminate signals, but I'm not even sure. Anyway, if we continue, it's now waiting for do fill, but we already did 0 and 1, and that's the whole range. And it receives the do fill signal. No, that's wrong. That is wrong. So the question is, I guess, how do we stop here in the debugger at the moment that it sends us the do fill signal? Well, that is being run from pipeline factory bottom multi-loop while loop. Or not. Pipeline factory bottom multi-loop while loop. How the hell is that sending a do fill signal? I don't see it. Set state will be printed. So I'm guessing that we fall through. Without actually changing the state to that. This should then happen. This state will be printed as well. It's not even printing that the state is changed. I think that's a path that we should follow. I do not understand this debug output. Hello A4 and a RIP spec. I don't understand my debug output. This clearly states that it is running this task, this state, and then sends a signal. But doesn't make sense. There's no signal here. I think it should print something else before the signal. I can find back where the signal is being sent, I think, because that must be this file. I think that's here. Line 689. Go to the top, yeah. Must be here too. I would say then it is running this state here, which is top multi-loop while loop. Not the bottom. Now we go back to the top, but it should print that to someone. Oops. No. This one. Somehow we get here in this state. Someone must set the state to that value. That happens there. And here. Run state is set to that. Would set state? No, wait. Anyway, the run state is set to it, and then we do a break. So maybe. No, also not. Why am I even setting run state to it? Oh, wait. Yeah. There is a for loop around this switch here. Super dirty. So by changing the run state this point and then breaking out of the switch, you go back to the top without printing anything. And then we execute this run state. Except that this set state should still have printed something. Set state of this one. Oh, I have ST verbose turned off, so that's why it's not printing it. Not printing set states. Okay, I'm getting it. Oh, I'm getting it. Yeah. So that's the route that we are following here. It executes this thing, and then it says if range counters is less than IN, so it does not reach the end of the loop yet, right? Then we go back to the top of the multi-while loop. Yeah, I think what I need to do is debug this function, like severely. I'm going to set a breakpoint at the top. Rather, let's say, at this switch here. And then we are going boringly to debug it. That is 557. Yep. Arthurs I do not use in IDE. Print run state. Yeah, cannot print that, but we should know what it is. This is threadpool 01. That is this. Pipeline factory start. Makes sense. To continue. Initialize. Still not interested, I guess. Continue. Again 5. Initialized. Continue. Threadpool 1. Running. Again initialized. Might not have printed it. Pipeline factory initialized, and that is, oh, pipeline factory characteristics initialized. Maybe it's time to step through. Yes, it's console with a K. It's a terminal. The Linux console is just that's not this. No, that's just pure text, full screen. This is a window. See, I have tabs here. So we're running pipeline characteristic initialized now. Prepare shared resource declarations. Initialize the range counters. The range counters are now why the hell do I have 4 of them? Okay, we have 4 characteristics apparently. Yeah, really? I think a vertex shader thing and a fragment shader thing and a basic characteristic. And I have no idea. I think that the length is just 1 larger for some reason. So we have 3 for loops. But 1 for loop just is no range, so it just runs from 0 to 0. Anyway, next. Now completed task is 0. I want to set a watch point on that just in case it changes. So watch the value of this address. It's kind of strange here. Oh, it just starts loops. Yeah. I have 3 for loops. Cannot. I was like, why is it not entering the inner loop? But that works a little bit different. Breakpoint. Okay, that's surprising. What's got print reinstate? I mean, human readable. I can just do step and then list. So running the top multi-loop while loop. Start of next loop. So now we are in the inner body. So whatever multi-loop did, it initialized itself. So now I should be able to print the multi-loop. Where was it? Range counters. It's still all zeros. And our current loop is 3. So that's the inner loop. And then we are going to set the pipeline index to 0. Set fill index. That's 2. So we have 2 tasks of the 3 that need a do fill signal. And so the 0 does not need a fill signal. That's the non-range. And then the other 2 do. And then we set it on the non-range anyway here, because it needs to run at least once. So now we have all 3 bits set. And then if it needs to do fill signal, and I don't think it does. I don't know. So it sends a signal to 1. Okay, so it skips 0. And when I do next, this thread really runs that task. Yeah, we don't need to see that, so I can just do next. And then this now I is 2, right? So we also need a signal. So we send that signal as well. I thought it would really run, so I don't understand why it's not printing the set index value. Yeah. Set state fit pipeline. No, I don't get it. Oh, anyway. Failed. Did we send any signals? Yes. Wait for all the characteristics being finished. return. So now I can do continue. Now they did run. So we have a vertex pipeline that started running with fill index 0. And we have the fragment pipeline characteristic range fill that was run also with fill index 0. So far so good. Stuff happens. And then the pipeline factory runs again with characteristics filled. So both have been filled now. Now, then what we get? Then we get preprocessing. Okay. 2 of them need preprocessing, so that would be 1, 2, and then more or less the same thing, right? So we just send the signals to preprocess 1 and 2, and then we're gonna wait for that they are preprocessed. So I do it again, I continue, and there was the preprocessing, and then we run the state. Where are we? I did next 738 here. Oh, that's preprocessed. That is now running. Go next. What's the pipeline layout? No, it's counting which needs compiling, so that's also 2. This is 1. And then the other one, and then actually sending the signals. That's the first signal. And the second signal. Now we wait until they both are compiled. So I do a continue again. That was compiling. Next list. Now we are running compiled. All characteristics compiled. State handle shared resource creation requests. Yeah, there's just a lot of code because now we're going to create a pipeline. That was the pipeline. And now the range counters are still at 0, 0. Yes, and now we're going to, 0, 0, 0, and now we're going to 0, 0, 1. Maybe we should put a breakpoint at 908 as well. Okay, I'll do continue. And now we are back 917. So the current value of the current loop is 0. What? It was already incremented. Anyway, I don't think we reached an end of the loop yet, so I do next, and then we should go to 919. Yeah. And then I can do continue. And now we're at the top of the while loop, and then now I can really print range counters, and we see 0, 0, 1. I think the first 0 is just to be ignored. So, okay, I think, so nothing special yet. This is going to be the exact same thing as before, right? Can I do that quickly? So I see 1 increment. I missed one apparently. 1 increment. Okay, what I see only 1 increment here. Oh, that's correct. Yeah. No, yeah. Because so there was 0, 0. Now we changed 1 to 1. So that one has to run. But the other one is still at 0. It does not have to run again. Okay, so we are waiting for, I think I'd have to do continue. So there was only one task now, the running fill. And that was a fragment. The fragment is apparently the inner loop. So that got to run, the fill index is 1 now. And the other one, which is the vertex pipeline characteristic range fill state, was not run again. Not with the fill index of 0. And then I do next and list. And now we are at filled. Next. So now we should also only have one that needs continuation with the pre-processing, right? 1, and that's it. Yeah, well, I thought it was it, but yeah. I mean, this thing is now just equal to 1. And then we wait for that to be finished. Now it's pre-processed. And then we run for the same thing again, but now we're going to compile, I suppose. Okay, I lost it. Where are we? It's the top of the while loop again. I don't know. I don't know what's going to happen. I think multi-loop is trying to change from 0, 1 to 1, 0. No, we're already running something. No, wait, I did just preprocess. We're compiling, I guess, whatever. No, now we're counting, sorry, I don't know what happens. Now we're counting the number that needs to be compiling. That should also be 1. Continue. That was 1 compile, I hope. Build shaders. Well, 1 call to build shaders then. 1 call to build shader. Compiled. Okay, next. Yeah, now we're going to create the next pipeline again. And now we hang. Bloody hell. It hangs. Ugh. That is not what I wanted to see. Which thread was this? Thread pool 1. That we are in, and the thread is hanging in sheetx wait. Why? So waiting for the mutex inside the lib NVIDIA GL core. Seriously. And is being locked by that one. It did 353. Yeah, this one, right? That will 4. And why the hell would threadpool 4 be trying to open def NVIDIA 0? What? That's 6. Dispatch allocated memory. VMA alloc. Create buffer. Totally unrelated. What the? Feels like I'm doing something wrong with thread safeness or something. allocate memory. Yeah. Sorry, the other one was third one. Yeah, I don't understand. If this one is waiting for this one on the mutex, and this one is not running, but why? Doesn't make any sense. Can just do continue though. Yeah, okay. Guess it was debugger stuff. Kept one of the threads running. Range counters are now 2. Oh, that must be the end of the loop. I don't think. Yeah, we should have only 0 and 1, so I have the feeling that we are now at frame there, and if I print this, that should be returned the 2. And of course, GDB has no clue, but I think that's the case. Let's just do a step. It's going to return this. How hard is that? That's 2. And then we have to compare that with that, which is, I bet, also 2. Syntax error. Yeah, grow up. It's time Linux gets a real debugger. I think this is the current counter. Current loop. I could have printed it, but I didn't. Or I can just print this. Current loop is 3. Oh, really? Yeah, that's the last one then. The last one of this one, which is length of 3. That's not good. I guess that it this returns 1 less, so we just get the last one. That's this one. And then the end of that, yeah, it's just going to be 2. Come on. Just, do I really have to print that? Okay, I'll print it. So that this is that pointer, and then I end. Or does it not want to do that either? It does not want to do that either. Maybe this is not the right thing. Maybe it's not what I think it is. Let's just assume that it is 2. Or I can step into it. See, it does -1, so it returns 2. Value. Oh, this is constructing something. Two. I don't know how, but I got a 2 on the screen. Is 2 less than 2? No. Therefore, we do not continue. We should continue with fall through. And get here, 925. Next, 925. Now we get our new code. And that says construct something from end of loop and then test if it is larger or equal to 0. Step, I guess. Now, is it continued? Nope. So we return current loop -2, which should be 1. And 1 is larger or equal than 0, yes. So we should get to 928. Now this is currently 0. And I is 0, I think. I is 1. Okay, 1. Next, and then we printed. Now it's changed. That was my hardware watch point. Right, so now that one should never be called, never get this to fill signal again. Plus it feels like it worked. Now we get next loop and then we get set state, stop. Run state, break, continue, next list. And we're running something that nobody knows what it is. It's just a top loop, top of the for loop. And we're going to test if we want to enter the while loop body. Okay, and we are at what? I cannot print this as usual, probably. Nope. Multi-loop is even too difficult for the debugger. Yeah, so this loop got at the end, so that one was incremented and the current loop is now 2. So 0, 1, 2. So this one is not initialized. Well, it's still at 2, but it's beyond the end. So that should be fixed before we actually start running. I think we got inside the inner loop now. Yeah, inner loop body. So now we have range counters is 1, 0. So yeah, we went from 0, 1 to 1, 0. But that's still true. Now we're going to do the set fill index for this one, and that's going to return true because we changed it from 0 to 1. And we're going to call set fill index, fill index, yes, for this one, also going to return true because we changed it from 1 to 0. But then we do not send a do fill signal to this one because it's completed. So I still want to have only one do fill signal. Okay, so this is not true, and I think it's not true for the first one. We would go back to top of the for loop. So next, 6, 7, 1. Don't tell me that it has to do, I don't know which loop is which. 0 is what? Nobody knows. Next. No, I want to do step. I want to see that we're actually calling set fill index. We are not calling set fill index. We're not doing anything. This increments I. We call end. No stepping. Calls on equal, so the value is compared with something 3. Oh yeah, right. And step. So now I is 1. Really, I hated to step through this. I think we should call set fill index now at some point. Just have to step a lot. Oh, there we are. Maybe. Again, no, not yet. Get value. Operator. Yeah, set fill index. Okay, so we're setting, I think this is done the outer loop, so we set 1, yep, and it was 0. And that means that it is going to be changed, so it returns true. And that means that this returns true. And then finally we're going to compare this with I to bit. That I would say is 2, which means that we would not get here, but that's super weird. That's really weird because this is the outer loop. It feels like I set the wrong bit. I think the completed characteristic task should have been 1 at this point. And that then of course explains the assert. I don't know. Yeah. So we're not going to do this for that one. And then this one clearly is the next one, I mean. Let's go to the set fill index again. You can kind of see from the call to set fill index. Here, which one it is. And this one is changing to 0 from 1. So this one should be suppressed, but it is not, because this is now 4. Well, that's surprising. Damn it. Nobody knows when this happens. Apparently there's a race condition then. Oh, right. Not good, but okay. Hasn't happened before, so probably a race condition that doesn't happen often, unless you are debugging and stopping the threads. But yeah, cannot have that, I suppose. Any race condition. Well, let me continue with what I was doing. Although now I need to know what thread we were in. 0001, I guess. That one, only we're still there, okay. And I was just incrementing this. It's still 0. Yeah, okay. And now we are going to increment it. So I think I can do it next here. I did a step and then I got in 670 again. I'll just step. Yeah, so this is... what is it? I don't know. Oh, right. Thank you very much for crashing on me, debugger. If I would live 10,000 years, I would so write my own debugger. But unfortunately, I don't have the time for that. And I already wrote a debugging library. Omnic is back. What to do, what to do, what to do, what to do, what to do. Yeah, now debugger, even DDB crashed. So I'm gonna go with the wrong index. The wrong bit was set. Pretty sure, I'm like just 100% sure the wrong bit was set. But I think Post Bunny did set the wrong bit. Can't prove it, but she looks guilty. Pipeline factory. Immediately after the for loop I, so that the loop is completed now. And then you're telling me that I set the wrong bit with that I. Then how can I make that work? Let's first look at what the end of loop returns. It returns current loop -2. -2. Okay, -1 gives current loop. The actual current loop. Like here. This gives the current loop while you are inside the loop. So the current loop is one larger than what we normally work with. The loop number starts from 0 and apparently current loop starts at 1. So n loops, then m current loop is 1 through n, and then what we work with is number 0 to n-1. And therefore we subtract 1 here. But we subtract another 1. Was current loop already changed at that point? I guess the inner loop means that... Yeah, see where the counter size thing was 4. Minus 1 is 3, so if current loop equals 3, we are in the inner loop. And we had 3 loops, so that was then 1, 2, and 3. That are the 3 loops, and then 3 is the inner loop. And this returns true when m current loop equals 3. So if we did not change current loop yet at this point, and we just left the inner loop, then this returns 1. 3 minus 2. And then we shift one place because it returned 1, and then we get 2. And I think it should have been 1, so we should have shifted it 0. But if I have a lot of loops, it's more like I need it inverted, isn't it? So it returns 1, but it should have been 0, or no. Yeah. Okay, I want to know if no, current loop didn't change because I know it returned 1. So current loop is the highest possible value. So what it returns is the loop number of the... Oh, right. Wait. Yeah, I'm getting it. That's why it says not the inner loop. I'm getting it. So we have a for loop. And then another for loop. And an inner loop. And then this is loop 0. I'll keep calling it I. I is 1, and this I equals 2. And then when we get here, that's how it works, multi-loop. So in this case we have 3 loops and we just left the inner loop, and therefore we are at the end of the previous loop, which is 1. And what I want is the loop number for the inner loop, namely the loop that we just left. So to begin with I have to add 1. Let's put this inside here as a comment. Bling, bling. 12 more lines. We are now at the end of loop code for loop I. So we do plus plus I, then set I to the loop number of the loop that we just left. Yep. So it was 1, now I set it to 2, and that's the one, that's the loop that we just left. And then I have to somehow convert that into a bit mask. I'm not sure if this is if now it is correct. I think it is. Yeah, probably it's already correct now. Let's try this one out. Omnic. Okay, let me check it out. What about your difficult decision? Okay, well, it looks delicious, but I only get 3 pictures. I cannot reproduce it from the pictures. No, I cannot. I cannot cook at all. You sent me 3 pictures and you think that from just the pictures I can reproduce that? No way. Yeah, I'm going to show it's okay, I'm going to show the pictures, right? Yeah. So that's picture 1. Okay, I would say that's a lot of meat. I don't know what kind of meat. There's just bone in it. Maybe I can find that back. And there is something on it. My guess would be pepper and salt, maybe. But the salt is not visible, so I don't know. Next picture. Tell me. The next picture is the same thing, I think, but then in a pan. The pan looks otherwise empty, and there is also something on the plate. Okay, so you put one of them from the plate in the pan. But there is something else added. I have absolutely no idea what that is. But it's not pepper. So, yeah, I don't know. You added something that I have absolutely no clue what you added there. And it sits in the pan now. And then the third picture explains it all. Ta-da! Of course. Oh, that's how you make this meal. Yeah, you're kidding me, right? I mean, if you ask me to boil an egg and you give me a precise instructions, I still am able to fail it. I don't think you have any idea how insecure I will feel while I make something like that. Think of a 4 or 5-year-old, I think, if you explain it. And they will fail. They will just mess it up anyway. And then start crying. Well, the latter part I probably won't do, but still. I'll probably understand that I will fail in advance, and therefore I won't do it. But yeah, it looks nice, but it's linking and it's not crashing. Something else happened. Why? What is this? Okay, I will try it if you give me precise instructions on how to do it and I understand them. But if you do something like this, then I just don't understand it. So then I cannot try it. Try what? And why is this black and white? Oh man. What an utter failure. Well, that looks good in the sense that it did run 0, 0, of course, and then one of them is changed to 1, and then the other one is changed to 1. And that's what I wanted. So I think the last change was correct then. But it's going to be a lot more clear if I increase the number of loops and the number of the size of the loop. Let's do that. Window.h. How can I make the number of loops larger? Oh, that's actually not that easy. Would have to add a dummy characteristic. Can't find it back. Comma 2. Let's start with making the loop, the range size 3. Let's make this one 4. Yeah, and you talk about meat, man. They want to make meat. They want to get rid of meat. I don't know. You didn't hear about that in the States? It looks like the USA wants to force Europe to do all kinds of things, and then they don't do it themselves. They want to get rid of meat. Yeah, you should eat insects. So meat is pretty much unaffordable. Did I just do that? No, I didn't. Let's run it again. Put it in a file and then run grep on that file. If I was in the right, I don't know, just get off. Fill index equals. So we start with 0, 0, and then the inner loop change to 1, and then to 2, and apparently to 3. So the fragment is the inner loop. And that one is finished. So now, then we do 1 and 2 for the vertex shader. Totally works. Now we get the vertex is the inner loop, apparently. Yep, vertex 2. What the hell is going on here? Fragment 0, vertex 0, fragment 1. Okay, fragment is the inner loop, I thought so. Fragment 2, fragment 3, vertex 1 and vertex 2. And then this is the end. So now we jump to the beginning again. And how does it finish? What the hell is it doing here? Okay, the validation errors are at least the way to find why it doesn't look good, I guess. Is the pipeline factory? No, it's still looping here. 2, 1. So we are going to create a lot of pipelines. Two, 2, 2, 3. No, this is the last one then. Yeah, now we start at the beginning. Okay, we just finish when we get at the end of the multi-loop. Yeah, okay, so they are destructed at the end. I guess as a result of finishing here. Yeah, the vector is being destroyed here, and that then destroys all the characteristics. Yeah, okay. I think there are. This one must be, or let's. I don't think it matters. This one probably still waits for the do fill signal though. Finish is being called. Yeah. Do send the do terminate signals. I guess that's good. That's what it's waiting for. Do fill or do terminate. I could terminate them before, but not sure if that makes any sense. Yeah, I have to go eat and stuff. There's one last thing I wish I could do. Let's understand if the characteristics are still accessed, or that I can just destroy them immediately. Take, for example, this one. We're running over a characteristic data cache, which is a list with this is just stored in the flat create info. Unlocked, sorry. Characteristic data cache. So it would destroy the characteristic, then this pointer starts dangling. But I don't think I'm using that anymore. I'm just looking if it is set at all. And then I use the cache. Yeah, so once I have this object, I look if this is non-null, and if it's non-null, I use the cache. So I think I could use, I could just use the destroy the characteristics, I think. Could. I guess it's not really important. Yeah, that was all. That's all what I did, but that was enough to stop it from calling, doing the do fill state again for the same value. Hey, 2 of them. Yeah, I just turned on the 1 extra pipeline. Okay, so I guess I can commit this. Just looked at that. Or not. Yeah, before it crashed, so probably the bug is already committed. Yeah. No, beep. No, don't. Run. Fill state twice for the same fill index. Okay, I'm gonna try and make some food. Or I could just go to the Chinese and order some. Yeah, that's a good idea. What shall I order? I almost typed in the. Yeah, now everyone knows where I live. Well, close anyway. Thank you, Google. Now I'll just go off stream, and then see if they have a website.